So obviously, given the amount of preparation, this GitHub stuff that we're going to talk about is very complex. But I think we got it covered. So let's start with this thing. There's going to be a couple of slides, and then there is going to be some demo if we have time for it. We'll try to get there. We've already talked about GitHub, but the purpose of this session, because we saw it was important last year when we talked to people, is to explain really how to deal with it. The problem with GitHub is that for many people, and I include myself, it is completely Chinese. I don't understand, well, not anymore because we made this presentation, but the terminology that is used is often very confusing, and while it's very powerful, it's not always obvious how you're supposed to use it. So GitHub is what we're talking about, and as it says there on the slide, what they try to do is to make a repository where development projects can be hosted. And not just a repository, but a repository that can actively work together with people developing the software, where it's easy to track changes, to integrate changes into a development project, and so on and so on. A little bit of history. We've covered this this morning to some extent in the presentation, so I'm not going to dwell too long with it. But together with PDF Toolbox 10, we released a GitHub and that had a place content template, a new place content template on it. And we kind of tried that to try things. That's what it more or less boils down to. And what has changed today is that if you go to the Callas software GitHub, it is now Callas software GitHub, and you look at what is there, you'll see that the amount of content on there is much more complete. And also that the way it's organized is a little bit different. We hope it is better. We actually have some questions about that as well. So if there is input, we are more than interested to hear that. And what we want to do is explain how you can actually get your hands dirty and start using this thing.
Now we're going to, or I'm going to explain some of the terminology, if I can't pronounce that correctly, the word, but the other words are much more easier to spell. So we start with repository. What is a repository? And then I will walk you through the different commands. So these words will also pop up if you use the GitHub repository and use the user interface in the web browser or on the Git desktop application.
And strange as it is, I think this is really the key to using it. It's very strange, but if you don't understand the terminology that they are using, and I don't think it is intuitive in all cases. If you don't understand what they mean with these things, you have no chance to use it in the correct way. I find that very annoying, but that's why we want to give you the explanation of each of these things, so that if you're using the desktop client or the website, that you know what they're talking about, and then you can do your advantage to it, because it's actually a very clever tool, but you have to understand how they want you to use it.
Yeah, that's true. So let me start with the main word that is used everywhere in the GitHub world. So that's the word repository. What is a repository? So a repository is a collection of files with a history. So each file in a repository has a history, and the Git, the most important feature of Git is to be a store that lets you maintain the history of changes in files. So that's the most important feature, I think, of all of these source code configuration tools. What's different with Git repositories to other tools that do similar things like subversion, or not subversion, but CVS and such tools, that a repository, a snapshot of a repository is always considered as one item we are talking about. So if I have in my presentation these little rectangles with rounded corners and with this funny hash value inside, this is actually a snapshot of a repository at a certain point of time. So that's a state of all of these files in a certain point of history of all of these files. So we have a repository having probably thousands of files just represented by this number. So this number is the hash value of the commit. We'll come to that later in the repository, and this defines the actual state of this version of all the files in the repository. So that's really important to get that right, because in other systems you get the history or a version number for one file in the history. In Git you have one number for all files in the repository. Okay? Then we see this little arrow here and this little name. That's something called a tag or a branch. So actually it's just a pointer that points to the version of the whole repository for a certain hash value. Okay. So what can you do with a repository? You can clone a repository. And the name is actually not very badly chosen, so it actually does what you normally understand under cloning. So it will create an accurate copy of the state of the repository on your local hard disk, for example. You can use just all the files. And Git will also clone the whole history of all the files. So you have the whole repository on your disk, including the whole history. So that's the other advantage of Git. It's a very fast system because it just maintains. I will not go into details how it does that, but it's very fast to create all these different points in history and allow for switching between these different points. Okay, so you can use, examine a cloned repository, you can look into the history, you can edit such a repository, you can fix bugs, you can add new features, of course, and that's all done on your private copy of a remote repository. For example, you could clone one of the callas software repositories and work on these files and do something with that. Okay, so once you have created a new version of the repository, you can save your changes to your local repository. That is called commit. You commit your changes to the repository. So you have cloned, you have a remote repository, you have your local clone of the repository, you make changes to some files, and then you have to commit these changes to your local repository.
The local repository,
yes.
Not
yes.
the remote.
No,
correct.
It's not the remote.
Local.
So that's a local. So you can think of it, the local repository is a database of all your files and all the versions of your files. And if you want to commit your local changes to that database, you have to commit that. Yeah? So what does it do? It takes the current, the last committed state of the database, that is the one you modified, and applies all the changes in all of the files in the repository, not just one file, all the files, create a new hash value or a new hash value in the database and move the master pointer to that repository.
So do you need to keep the file names?
No, you don't have to keep the file names. You can change file names in Git, definitely. Yes, you can. Yeah.
But what is very important is this point about local and remote. Callas Software has this GitHub repository online. When you make a clone on your own computer and you commit changes, we actually don't know anything about that.
No.
That's just on your local machine.
What's the benefit for me to have that on my local machine? It's compared to just having the files.
You have the history. That's the main benefit.
Yeah.
I have my own history.
Yes, you can go back and forth. You can just pull a recent version and use that one and so on. Probably you made a bug in the latest version, and you can just go back. You can view the history. You could do diffs and such things. So that's actually a very good tool for local text files just without any remote repository. It's very powerful.
But there is also still a benefit working with this online repository, but we come to that. But if you talk about just commits, you're dealing with your copy of the files on your local system.
Yeah. Okay. So, to make things even more complicated, we can do branches. So we can have two different or as many different versions of the repository at the same time inside our local repository. So we can just say, okay, this is a stable version, I give it a name, I create a branch, so now I have two threads of history, so to speak. So in this case, I just create a new name. It has a pointer. I have a new repository again. This square reflects all the files in the repository, not just one file. So that's my master, and I have a bug fix branch, for example. So I can work on that. I can create new revisions here. So each of these squares is a commit. Yeah. Okay. Then I can merge back changes I made in one branch back into the master branch. So there's a very easy case. That's if I only have changes on the branch and I have no changes on the master branch. That's easy. So I can just do a fast forward merge. That means it's very quick because the only thing I have to do is move that master pointer to the next commit. So it's a really fast operation. And such things are not fast with other tools like CBS or so. If you go back to another branch, it takes half an hour for the source code of PDF Toolbox, for example. So if you have conflicts, it's a little bit more complicated. In this case, we have 4 commits in our repository. So we started here, we made one commit, we created a branch, made a commit on that branch, and made another commit on the other branch. So now what shall the system do if we want to merge the changes in the branch back into the master branch? Git is pretty good in doing that automatically, but even if it not works, it gives you tools to indicate conflicting parts in the source files. So once you have conflicts, you have to resolve them, and then you can merge the changes into the master branch. You can even merge in any direction. You could also have merged the changes from the master branch into the bug fix branch, so that is possible as well. So in the Git system, 3 commits are involved in doing a merge, so that's why it's called a 3-way merge, because the ancestor of the commits are taken into account, and the two revisions on the two branches involved are taken into account, and then Git does its best to just merge all of that. But if David did a change on line 15 of index.html, I changed the same line, there's no way around doing it manually. So that's clear.
Yeah, so as long as, just to make sure that we're clear on that, you have a collection of files. If Ulrich changes one file and I change another,
yeah,
then GitHub is smart enough to be able to figure out that what we mean is that both of these files need to be changed in the resulting commit, yeah, in the merged. If Ulrich changes one file and I change the same file, now we have a problem, because who wins? And then there are tools to manually see what has changed in these files and to indicate which of these changes you want to accept. And it could be that Ulrich loses and my change is accepted but not his, or vice versa. But it could also be that we worked on different parts of the same file and that they both are accepted. And once that conflict is resolved for that particular file, then you can do the merge safely, because then there is no conflict anymore.
Okay, so up to now I only talked about local repositories. Now we talk about local repositories and remote repositories. So these yellow, green, I don't know what the color. Yellow is okay. The yellow squares are placeholders for example, color software repositories on the GitHub cloud, and the gray ones are placeholders for local repositories. So actually this one should have both colors, because that's the first initial state of the repository after I have cloned it from the color software repository. So that's the origin master tag. So that's always seen also in GitHub repositories, such tags. Origin normally denotes repository origins. So that's the origin of the repository, and that's probably, for example, from the color software GitHub repository. So we created a clone for that. It has the origin master tag, and now some work has been done. So we worked on our local repository, making 2 commits, and David also worked on the color software repository, also made 2 commits. It could have been 3 or 5 or just 1. But the interesting thing is that we now have new revisions that are not known in the local repository, because we did a clone and we did not update the repository. So what we can do is do a pull. And the pull fetches all the changes from the remote repository and merges them into the local repository. So actually there are different words for that. So just getting the remote content is a fetch, and a fetch followed by a merge is a pull. So that's what they call that.
So once more, looking at it from your point of view, we have this. We have a report template on GitHub. You're interested in the template, so you're going to create a local version of that. You do a clone, basically, yeah? And then you start working on that, and you use that to implement your own report. While you're doing that, Ulrich or myself fix a bug and we publish that to the online version. Now there is a problem because we fixed the bug, but it only exists online, it does not exist locally. Doing this pull would take the bug fix that we did online and merge it with the changes that you have already done locally. And that means that your local system, it still has your changes that you've done, but it now also incorporates all the changes that were done to the online version. So talking about benefits, it means that you can have something locally that you have improved, but you can still benefit from any bug fixes that we do in the online version by pulling those changes in at the time that is convenient for you. Probably not the day before you use this for a customer project, but when you have the time, you look at what has changed online and you do a pull of those changes to your local version.
Yeah, you always have the history, so
yeah,
you can go back.
You can go back, correct. But I would rather not.
Yes. So, okay, so after the pull, the master pointer moved to this revision, and just one question for you. Do you think that these two repositories are identical or not?
Yeah, the lower one has my changes.
Yes, correct. So after the pull, after pulling the last state of the repository from the remote, from the origin master repository, you have a version containing both your changes and the changes from the master.
But what happens if I already fixed the bug locally and my bug fix is better than yours?
Then you get a conflict.
Yeah, it's not possible.
Because normally the bug fix would involve the same file at the same line number,
Yeah.
I suppose. So, and then you get a conflict and you have to decide. And
Yeah.
then in this case you would obviously say my fix is better than theirs.
Well, I will give yours a try.
Yeah, but we come to that later. So another possibility is to let us know.
Think of this as the egoistic way of working with GitHub, if you want. You take all of our improvements and you give nothing back. You just improve your local version, but you keep it to yourself. There is another way that I think is better, but we'll come to that.
Okay, so now the other way around. How can I submit my changes to a remote repository? So it's called push, and a push will just move. In this case, we have no conflicts, so that's easy. It will just move the origin master pointer to my repository. Actually, it will upload the files and will find there are no conflicts, and it will just move the pointer forward. But that's nothing you can do in our repositories because you are not team members.
Oh, we can.
We can, yes, but you not.
Yeah.
So, what do you have to do in order to do such things? So in this case, you have to create a fork. Yeah? If you want to collaborate with us, you have to fork a repository from Callas software. So it's different to a clone, because a clone is just a copy of the repository on your local hard disk without connection to our repository. So it's just a clone. And the fork is a clone with a back reference to the original version of the repository. So it knows it's coming from Callas software. So this is the repository on the Callas software GitHub, and this is your fork. So it's a clone with a back reference. And it's your clone, it's your fork. So it belongs to you. You need an account for that on GitHub. A free account is sufficient, but only if you want to share your bug fixes in your fork with all others in the world.
And you don't need to talk to us. You just need an account on GitHub. You can fork this without ever talking to us. Yeah. Great.
So, and then you can fix bugs or create features.
Or try to.
Or try to. You can submit so-called pull requests to us. So pull request, so you have again the word pull. This time it's the other way around. Yeah, because we want to pull your changes into our repository. So you send us a pull request, and we look at it, and so that's from the GitHub page from help.github.com. Pull requests are proposed changes to repository submitted by a user and accepted or rejected by a repository's collaborators.
For me, this is the most confusing thing in there, but actually it makes total sense.
Yeah.
But you have to go through all the different. I think it's the first time I actually understand why they use this terminology. Yeah, because you've made changes, you think your changes are great. This is not the egoistic way of working with GitHub. So you want others to profit from your changes. So you're telling us, hey, I've done something here. Could you please look at it? And if you also think it's good, pull it back into the master, the online version of the repository, so that others can also use these changes. That's why it's called a pull request. You don't have the authority to simply push it to our repository. You can't do that because you don't have access. But you can ask us to fetch the changes and integrate them. It's great.
Yeah, I think the most confusing part is that the pull word is used in both directions. So, but that just reflects the symmetric way Git is built, because in the Git world there's no instance that is better than the other one. So with GitHub it's different, because GitHub is the repository is owned by someone, but from the pure Git implementation, it's just two repositories which are connected by a fork, and you can pull in both directions. You could also push in both directions, but I don't think that's supported in GitHub. Okay, so how does it work? You log into your GitHub account, you fork a project from GitHub Callas software, you make changes, and you create a pull request. Okay.
So what you find on there at the moment is what you see on the other screen. At the moment, we have created.
Should we probably switch screens?
No, it's okay.
Yeah,
that's okay. At the moment, I just need to figure out which finger I need. There we go. We've created 4 repositories. One of them doesn't make sense. It's a test repository, so you can use that to play with it if you want. That was the intention, at least that's this test thing. The other 3 are actual content already. And our expectation is that there will be more content that is added. And actually, we are not 100% certain that the way we've split it up today is the best way to work with it. So if someone has input to that or comments, then feel free to bring them up. We will be more than happy to have a discussion about that. But right now, you have a project called Place Content, or I should use the right words, a repository called Place Content. There is a second one called Pre-Flight Report, and a third one that is snippets. The first 2 should be relatively clear what they are. The last one perhaps needs a little bit of explanation. But if we start with the obvious ones, under Place Content, you find a bunch of Place Content templates. On the 4Ps repository that we had before, there was one. You had this template that you could start from for a new project. What we've done is we've added all the other Place Content templates that are used by fix-ups you find in PDF Toolbox. So it's a convenient way to look for something that comes close to what you might be using yourself, and then you can either just copy the files or you could fork it, I guess, if you want to continue working on it. Next to that, you have, I'll do pre-flight reports. You have one that is called pre-flight reports. At the top, you have the pre-flight report template, HTML template, that is included with PDF Toolbox. So if you generate a custom PDF report, this is normally the template that is used. If you want to make changes to that, you can. I would suggest that you make a fork of this thing, that you make your changes, correct the problems that exist in there, and then you tell us how to solve them. That would be much appreciated. But there are some others that got added as well. The next two are report templates that are already a little bit more configurable. Those are two things that I made for a session at one of the previous VIP events, I think, at some point. The last one is one that is completely new. It's also a report template, but it's one that I created because, well, I needed something to play with this. But also, I have a lot of feedback from what people tell me when they do pre-flight and they look at the default report, and I thought, why not use what I learned for place content and make a report template that is a little bit better based on that. And what it will currently generate is something like what you see there. So it's a little bit more compact than the existing template in PDF Toolbox. It also has some improvements. There is some additional scripting that is in there that does nice things, like if you look at the trim size in here. So look at the summary header here. It actually detected that this is 297 millimeters by 210 millimeters, and instead of giving you the dimensions in millimeters, it tells you that it's an A4 portrait. That should be 210 by 297, I guess, but anyway, it's A4 portrait. And if you have multiple pages in a document and they all have a different size, it will also give you something that is reasonable. Yeah? What it also does is it doesn't give you all the different icons for things. It just tells you that it's either good or not good. And there is some geeky stuff in here that, for example, I can change the background color of the summary. Right now it's red, this light red color if there are errors. If everything is okay, there is a green check mark here and the background will be light green. I don't think anyone would actually want to use this, but it's kind of cool, so it's in there. And it's easily adjustable by, there's a preference file in there that you can change, and then the pre-flight report looks different, and you can use it to, for example, decide whether you want to see errors and warnings or only errors, and maybe you don't want to see fixes, and so all that is created or is controlled by preferences. And if you want to play with it, again, you go to GitHub, you fork this pre-flight report repository, and then you can make changes and fix the bugs that I'm sure that are still in there, and create a pull request so that we can integrate your bug fixes in the online version for other people. And then the last bit that is in there is this, and we will talk a little bit more about that in tomorrow. This is also definitely still a work in progress, is some snippets. Each of these, so I can look at the pure JavaScript snippets or the ones that integrate with PDF Toolbox. And what you have in there is, if I take functions, for example, I have a file that isn't a complete JavaScript file, but just gives you examples of how to do things in JavaScript. You can also do Google search for things, but if you want to know how to write a function and you forgot, which happens to me all the time, I have to admit, then you can come here and it will explain
what the options are that you have. In some cases, that's just copy paste what is here, and then you modify it for your own project. So there are some pure JavaScript snippets that explain how to do things simply in JavaScript. Then there are also some snippets that integrate PDF Toolbox functionality, like how do I get the name of the file that is being processed without the extension, which is one line, but it includes some clever regular expression stuff. And trust me, you don't want to figure that out yourself. You want to copy it from somewhere. So this is a place where you can find stuff like that and copy it. And feel free, again, to fork this and provide your own snippets in there. We will be more than happy to include them in the repository. So I think that's it's not all we wanted to say, but it's all we have time for. Any questions? Anyone who's forked this already? Good, good. So we should probably be able to see that somewhere. Actually, if you go to repository on GitHub, but probably you cannot see that, we can see that. So if you would make a change and you submit that to us, then that will end up in our list of things that people have suggested, and then we have to approve, and it gets imported into the online version of the repository. So go ahead and try these things. Okay, then thanks very much.